One of the plots that we spend the most man hours on, both employees and farmers, is our hybrid characteristic plot, where we're trying to collect characteristics of a hybrid to help our farmers use those in management decisions and positioning that hybrid where it is. All that data eventually ends up into what we call a yearbook at the end. What we're going to be working on here today is ear flex. We know if we plant a population low, we're going to get a big ear, and as you increase the plant population out there, the ear is going to get smaller. That's pretty obvious, but we want to know how it gets smaller. Is it in kernel number? Is it in kernel mass? And if it's in kernel number, is it in length or is it in girth? So that's part of what we're doing here today to figure out how these hybrids respond. For some hybrids, they'll respond in girth, and we'll see the shutdown in the kernels around. So going from a 16 to a 14 or 18 to a 16, and it's happening only with population, and it's happening early in the season. So the stress of population, this hybrid wants to shut down to kernel girth. That changes how we would manage that hybrid. Versus other hybrids that don't change in girth, and they may not change in kernel number, they're just going to change in kernel size. In this case, you're going to have less starch per kernel. So the kernel count would be the same, but the weight's not going to be there. And some will change in length, where they will abort the tip. And it depends on when they abort the tip, how we manage that. So if we abort the tip early, then we're talking about stress pre-tassel. But if we abort the tips later for some hybrids, that's post-pollination. So that would change how we manage it. This is back-end abortion that's taken place. And for some hybrids, they're going to hang right in there until we get to that mid-milk dough stage, and they're going to start to throw the tip off. That tells you, again, where its stress level is. It's got plenty of kernels, and now it's adjusting to what it's got to fill. So we call that, again, two different versions of length. We call it L1 in length, happens before pollination. L2 in length happens after pollination. And, of course, G for girth, kernels around, and then kernel mass, depth of kernel. How many kernels does it take to make a bushel? So we're going to walk you through kind of a step-by-step process of how we get to the end or get to the data collected. Of course, these plots are out in the field full scale, and the guys are out there harvesting them with scale carts and combines. So we have the actual combine weight between 22,000 and 36,000. And then the crews go out there and they collect an ear sample. Now here's where we're pretty particular. We're looking for a row at 22,000 picket fence stand, photocopied plants, the well emerged together. We're not only looking for one row, we're looking for 3 rows, and then we're harvesting the 10 ears off of the center row. So we want to know how this ear looks if it is in that perfect environment. We can't pick a gap, or we can't pick a late emerger, we can't randomly pick them. We got to say, based on what 22,000 would give us in sunlight, how does that ear develop, and compare that to 36,000. So that's done shortly after black layer. Our crew goes out and they look for 10 good representative ears that will represent that plot. Of course, this plot is replicated 3 and 4 times across the customer base. Usually after black layer, slightly after black layer, and we'll come in and hang them here to dry so they'll be ready for us to do the hand harvest. At that time, we can usually pick out some of the refuge in the bag based on plant style, tassel type, ear type, but we try to eliminate refuge in the bag from getting into the sample, mainly because you don't get the same refuge in the bag every year, even though you're buying the same hybrid. From there, they come in here and dry, and then we'll start the process of husking and weighing these ears. So after every ear is husked, it's going to go into the counting bin, and we're counting these 10 ears. They're counting around and they're counting long, and in this situation, it's written on the ear and it's written on the sheet, so it can be data entered later. But we know how many kernels are in each ear of the 10 ears. After the ears are counted, girth and length, then they're weighed. So we have a total weight of kernels and cob at this point, and it's recorded. Now, between the two of these, it gives us another place to look for abnormalities such as refuge in the bag. So for instance, if all of them are 16, but all of a sudden there's one row that's 12 around in girth or way off in weight, that's a signal that that one may need to be thrown out as a refuge in the bag, and we can pull it out of the data set without ruining it. Once the counting and the weighing is done, then they go into a photo booth, and we line up all the ears for one population, and we take pictures of it. That way we can compare the two different populations. This helps us a lot, especially in figuring out, is it L1 or L2? Did it flex before pollination or after pollination? It also helps us to throw out the outliers. Again, if there's a definite difference in kernel color or shape or that type of thing, you can see it in the pictures. So the next step, of course, is to shell this corn. We'll feed the ears through the sheller and we'll be able to weigh the grain. We'll know what the weight is in the cob. It also gives us an opportunity to look at cob color. So if we see difference in cob color, let's say white versus red or dark versus light, that tells us again we have the potential for refuge in the bag. That can be marked on the sheet as, again, data to be cleaned up. That corn then is weighed at each individual ear. Then we put the composite sample together and we then run test weight and moisture on that, and then all of that gets data entered into a database so we can sort through that data and make sure we have it all for our hybrid yearbook.